Hey, welcome to Graphics Programming Accelerators. Today I'm gonna create Windows application using Rust and DirectCompute. First of all, I need to add dependencies. Dependencies are stored in file named cargo. I have very many dependencies. One of them is system dependencies and another graphics Direct3D dependencies. Okay, now let's start our main function. Let's add com initializer. And then let's specify viewport size and window title. Import all dependencies. I'd like to create a simple user interface, and that window will show adapters. Adapters list shows all available adapters in our system. Then I create window using function create UI. This function has following arguments as viewport size, title, and adapters. Then I show window and run message loop. Now I need to get adapters. So let's create a new file for DX game class. New file DX game. Let's create structure DX game and implement it. implementation of this game has getAdapters method. This method returns adapters list. So I create vector with adapters descriptions. Okay. And to get descriptions, I need DXGI factory. Let's add one before adapters declarations. So I call standard function create DXGI factory 2. This function returns object factory object. Then I use this object to enumerate all adapters. I use for loop to enumerate adapters, and I use enumerate adapters function in DXGI factory to get each adapter. If there is no adapters, then this object called adapter returns 0, and I just break this loop and exit. Okay, then I get description, adapter description, structure, and fill it with get description function. Then I add this description to my vector. Let's use new file in main file. To use DXGame, I need to add keyboard mod and DXGame. Then I need to use created structure DXGame. Let's return to DXGame and add all necessary required libraries. That will be DirectX, Windows, and so on. Okay, now let's add window structure. For window structure, I add another file. Let's call it window. this structure will use game type to specify game realization. And let's add implementation of this structure so we can create window. In the main file, I add dependency to this file, to window. It is similar to this game. Mode window and then use window. Okay. Let's create simple menu for game controls and accelerators. So we can choose accelerator to run our game on. Another file I need to add is game. This file will contain game interface. Our game has constructor which accepts board size, window handle, adapter index. Also it has update function and render function. Also I need to set speed of the game and get memory usage. Current memory usage will be useful for debugging purposes. Let's save this file and add this file as dependency in window rs. Also, I need to add game in the main file. Okay, now let's add another dependencies in window. To window, I add all graphics dependencies. Okay, another Okay, let's add menu. I'd like to add a gameplay menu. This will be normal speed. Then I need faster sub-menu and it will be 10x speed. Then I add pause submenu and another memory is H and exit submenus. Let's implement create UI function. First of all, let's assign viewport size. Then I need an instance of model. Then let's register window class. Window class has window procedure. We can specify it later. Let's create menu now. I create menu and get handle of the menu. Then I create submenus. First submenu will be file game. I add submenu using append menu. So this is game and another sub, and game has play submenu. Also add play faster. As well as pause, separator, and let's add memory as H menu. And after separator, the last submenu item will be exit Okay, now it's time for accelerator submenu. To add accelerators, I use for loop. Inside the loop, I get description of adapter as well as memory. Dedicated video memory divided by 1,000,000 to get megabytes. And the last thing I need to add is append this title to submenu accelerators. For each accelerator, there is item ID that starts from 200 and it increments for each accelerator. To compare performance, we can add another accelerator, for example, central process unit, or another one. So that's it. All I need is to add accelerators to the main menu. After this, main menu is done, and I can adjust window rect for our viewport size. Adjust window rect. After adjusting, I get new width and height. Eventually, I can create window using new width and height of window as well as main menu. Like here. Okay, last thing I need to add is window procedure. Window procedure function is simple. It responds to message destroy window when we call destroy, when we call exit window, vim destroy message is sent to window, and then we just post quit message. Okay, let's try. Okay, there is some errors. I need to implement new. Okay, here is new. Let's choose debugger. In the launch JSON, I add configuration for debugging. And I add prelaunch task. So let's create file task.json. Tasks.json. For this task, cargo build. So before launch, cargo try to build our project. Every time I press F5. Okay, let's try. Now there is building of our project. Okay, I need just add some dependencies. For example, window handle. Okay, another thing is no such associated item. Okay, our DX game needs implement game interface. Let's add empty implementation. Okay, I add simple empty implementations, and the last thing is run message loop function. This is important function. Let's add it to window. and implement. So run message loop. Pick. It picks message. If picks message is true, then it translates message, dispatch message, and break from this loop if there is quit message. If there is command message like user choose menu in the main menu, and another update and render. No method. Okay, let's add empty method sample window proc. Okay, I have menu, I have accelerator submenu with available accelerators. Also, I have main menu to control game. Nothing works because I need to specify corresponding action. Okay, let's do it. So let's add matching comments. This, if I choose accelerator, new game created with selected adapter index. If I choose gameplay, different speed is set. If I choose game exit, window is destroyed. I need to add message box function. This is simple function that simplifies showing window. It just call message box. Also I need get game. So our window will have game structure. Yeah. And this method just returns this game structure object. We need to select accelerator or adapter first. Okay, let's try again. I click game menu and exit. Okay, it works. I can see memory usage. Oh, yes. If I didn't select accelerator, I got error. Okay, let's select accelerator. Okay, not implemented, of course. I need to implement new game. Okay, to create new game, I need device and device context. To create device, let's add a wrapper library. This library will have all DirectX stuff, like create devices, create swap chain, and other objects. So let's create a DirectX 11 file. The purpose of this library to make our code more readable. For example, to create a new device, I need DirectX configuration and descriptions. Also, I need unsafe block, and this library hides all that stuff. It just calls create device, and create device returns actually object. After adding DirectX file, I add it as mod DirectX in the main file. Now I have all needed stuff. For example, create device. Create device calls create device with type if hardware unsupported, and then it calls create device with type warp. Okay. Also, I specified the debug name for my device. It can help when I debug. So let's continue implementation of new method. Let's create swap chain, get backbone buffer, render target view. Also, I need texture to draw on the screen. And an ordered access view to link this texture for shader. Let's add another variable, board cells. I needed to create initial position buffer. Initial positions has initial positions of each element of the game. So each pixel of board has position and velocity buffer. To create these two buffers, I need vector. I need vector to create initial positions, and initial positions will be 1 and 3 on this line 500 by height, and I start at the pixel 900 by horizontal. Let's create initial data sub-resource, and finally I create position buffer with initial data and debug name position buffer. Then I create position buffer view and velocity buffer. Velocity buffer is empty. By default, it has zeros, which is okay. Initial velocity is 0. Then I create a game shader object, and this object I will create from file. We will create game HLSL file later. After creating game shader context, I set it. Game shader object, I set shader using context. And that's it. In the end, I need just add all resources. So our DirectX objects will be stored in one structure called resources. Let's create resources structure. And I add this structure and other things to this game structure. Resources structure is simple storage for all DirectX objects. actually DirectX resources. You can see it has device, texture, unordered views, and buffers. Okay, now let's implement update function. Update function is very simple. It gets resources and for each generation it calls dispatch. Dispatch function will run our shader with corresponding amount of threads, groups. Number of groups is width of viewport divided by 30 or height divided by 50, 15, and that's it. Let's implement render function. A render function will be simple too. It calls clear context render target view with specified defined color. Also, it copy resource from texture to back buffer and presents back buffer to monitor. Set speed function is just sets generations per update value, and get memory usage is interesting function which gets adapter from our device and tries to get video memory information. And this video memory information has current usage and overall budget. And that's it. Our DXGame file is implemented. Okay, let's see what we need else. Of course, we need shader file to implement our game rule. Game shader file is named like game HLSL. Okay. This file declares a texture for screen to output current state and two buffers for positions and velocities. Then I specify number of threads in each group and actual implementation. Here is width of viewport and main function specifies coefficients and constants. Okay, this is a shader and I need to copy this shader to output folder. To do it automatically, I create another file called build. build rs, and this file just copies my game HLSL to output directory. Okay, so now I can run and see that my file shader game HLSL is copied. So to run game, I need this file to compile and create compute shader. Compute shader is used in DxGame. Create compute shader. Here, create compute shader from file. Okay, and this file needs to be alone and beside main execution file. Okay, let's see that everything is implemented as intended. So this is main file. Okay, game file is just interface. A window file has all functions: new, menus, window procedure, run message loop, simple window procedure that calls game functions. So window is connected to our game object. Okay, it also has utility function like message box and get game. Okay, seems to be okay. Let's check DxGame file. DxGame has resources, DxGame structure, implementations of get adapters, and implementations of the game. Okay, looks like everything is fine. Let's try. Now I see window. I can choose accelerator and run the game. Okay, I see green and blue colors that grows up. Let's play faster. Okay, it works. Let's pause. Let's see memory usage. Okay, it's 44 megabytes, and I have 7 gigabytes of memory. It's because I use Intel UHD graphics. Okay, let's continue. So my bubble rises and reflects from walls. Virtual walls represented by window boundaries. And that's it. You can change initial conditions here. For example, you can change form of bubble. Let's try this configuration. Okay, it's unseen. It's not visible. Maybe I need to specify 3 here. Okay, it's very simple. It's so small that I cannot see it for long. Yeah, it's very small. Okay, that's it. Thank you for watching.